I, Professor Zubaye Ekpete, welcome my students and viewers to this class. The topic we'll be considering is on errors. But before we continue, we'll have a recap of our last class, where we talked about the process of analytical chemistry. We defined analytical process as that sequential step which we undertake while performing an experiment. And I said that there were 7 steps. First, define the analytical problem. Second, select the method of analysis. The third, sample. 4, sampling preparation. 5, measurement of your desired constant. 6, calculation of your results. And 7, evaluation and reliability. At the end of this class, the student should be able to understand the following objectives. What are errors? Types of errors and laboratory implications of errors. In every measurement, there is no way we will not have an error in that measurement. But the analyst is trying to have a result that is very close to the true or standard value. So the error is the difference between the measured value and the standard value. We have positive and negative error. What is a positive error? A positive error is that error that is you obtain that is higher than the standard value. That is, your measured result is higher than the standard result. It gives you a positive error. But when the standard result is higher than the measured result, it will give you a negative error. In analysis, we don't bother about the error, whether it is positive or negative. But what error does is to show you the magnitude and direction of your accuracy, if your work you are accurate or you are not accurate. What are the different types of errors? We have determinate and systematic errors and random and indeterminate errors. What are determinate errors? Determinate errors are those errors that we know their causes. You can trace these errors to something. Those are determinate errors, like the methodic error, operative error, instrumental error, proportional error, and additive error. I will consider them individually. What is a methodic error? Methodic error is that error that we obtain from wrong methods. The method we have not followed right, and we have methodic error. For example, when titrating a strong acid and a weak base, you are expected to use a metal orange indicator. But in that process, you will now use phenolphthalein indicator. You are not going to see any color change because the phenolphthalein indicator shows its color change at the range of 8.1 to 10. So you have shown that you don't know the method. It's very important in analysis that you read through your method before you commence. Operative error, the second one. It is caused by the operator. That is you, the researcher, due to faulty judgments. If you used to add extra 0.2 mil in a titration before you get to your endpoint, you have added extra. Some of us are color blinded. You find out that you have introduced a positive error of 0.2 into your analysis. So it shows for carefulness. Another error is instrumental error. This one may be due to poor calibration of the equipment. Example, if a pipette is calibrated to take 24.5 mil instead of 25 mil, an error of 0.5 has been introduced, and such an error is a negative error. That is why it's good to buy from very good manufacturers. These are our equipment for us to avoid these instrumental errors. Another error is proportional error. In proportional error, there is in that measured quantity a consistently either higher or lower value that will be obtained than the titer value. Your value will always be higher or lower than the titer value. It is usually caused by maybe issue of measurement or procedure or poor calibration also. It can also be caused by an impure sample. For example, if an expected titer value is supposed to be 10.0 mil, and because of impure sample, you now got 10.2 mil as your measured value. An error of 0.2 has been introduced into that experiment. That error can be lower or higher, as I just said. Another error is additive error. This additive error is an error that is always in a series of determination and is independent of the amount of sample taken for analysis. It is always a constant error. For example, if in a titration you are expected to have 12.0 mil as that in that titration, but your measured value is 12.1, it means that an error of 0.1 has been introduced. If we double that sample to 24.0 mil, you will get a measured value of 24.1 mil. In additive error, that error is always constant. You can see from this explanation, there is always an error of 0.1. Such an error is additive in nature. How can determinate errors be minimized? Determinate errors can be minimized by the proper calibration of equipment. It's important that we calibrate our equipment before using them. And it's also important that we have good equipment, well-calibrated equipment in an analysis. Secondly, we run a blank determination. A blank determination is very, very important in an analysis. What is a blank determination? It is a determination that you perform without your sample. You have taken your own measurement with your sample inside. Running a blank, you can use water, and then you use water and perform an experiment. It will always give you a result that is lower than the one you obtained from your sample. And you subtract the both. As you have subtracted, you have corrected that error. The corrected value now is your real value you will use for your analysis. Another one is repeat and replicate experiments. Experiments are not done once. Every researcher must do up to 2 or 3 times. At times, that is why you always say in triplicate determination. In replicate determinations. These determinations we have done will help you to have the mean or the average. At times, you get your standard deviation from it. What are indeterminate or random errors? These are errors that we do not know the causes. This type of error, we do not know the cause. This error could be caused by vibration of your equipment. Maybe a heavy-duty truck passing through that environment, and then you are in that lab that is facing the major road. As that heavy-duty truck passes, it will cause a vibration of your building. And if you are conducting an experiment at that time, it will introduce indeterminate error. It could also be caused by passing traffic. And it could also be caused by variation in temperature and limitation to scale reading. These are the causes of indeterminate error. How can these errors be minimized? These errors can be minimized when we have a control experiment. In most experiments, when you do your determination, you also have another control somewhere you will run. You will also analyze your data statistically. That statistical analysis here now, it means that your result, you will not just get it once, thrice, twice, get the mean, thrice for you to get the standard deviation. You analyze it, and you will seek expert advice. You can seek expert advice. By this, you have corrected your indeterminate errors. At times, they also say you can correct it by increasing your sample size. What are laboratory implications of errors? If you are not careful with the analysis, definitely you are going to have inaccurate results, which will just make your result nonsense, rubbish everything you have done. And you have delay in the progress of your analysis. You have your reputation damaged, and you also know that you may not have regulatory compliance, so you have issue with the regulatory bodies. Another thing, you have loss of confidence. As a researcher, the moment you produce one result and it's not good, even the zeal to continue will not be there. You would have wasted resources, my dear. So it is very, very important while we are analyzing to prepare ourselves for that experiment. And that your result cannot be reproduced, because every researcher or scientifically, our results are supposed to be reproduced. That is why we must know the method very well, because somebody else can try out our method. And then you may have ethical concern. This one concerns the medical field, especially pharmacists. We always know that in Nigeria here, most of them have produced bad children syrups that have led to death. And that is why every analyst should be helping himself, him or herself, to avoid errors in our work. In the next class, we will be talking about calculation on errors. Thank you for listening.